So in this video, we will see how to use lambdas in conjunction with functional interfaces. So in the last video, we created our first functional interface calculator, and this is tagged as functional interface annotation, although this is optional, but it's good to add. Then it has a single abstract method calculate. Now, in order to use this calculator, one way is to create the implementations or create classes implementing this interface. So we added two classes. One is sum that implements the calculator and gives the implementation basically to perform the summation of the numbers. And similarly, we have another implementation of the same interface that implements the method to provide the implementation for multiplication of two numbers. Now, I know that this is not the best implementation of the calculator. There are easier ways to implement a calculator in Java, but this is just to show how do we use functional interfaces, and it basically represents a pattern, a problem pattern. All right. Now to use it in the main method, I have added a new calculate ops method which accepts an instance of calculator, or basically an instance of a class that implements this interface, and along with it there are two input method parameters, method arguments, and the method will simply call the calculate, this method basically, and it will pass the two numbers. So in this method there is no implementation. The implementation will be passed down to it in the form of a class that implements this interface. So for example, to perform the summation, we instantiated this sum class, and then we called the calculate ops method. We passed the instance of this sum class and two numbers. Now I hope you recognize the coding to supertype, where on the left hand side the reference variable is referring to the parent type or the supertype, in this case interface, and on the right hand side the actual object that we are creating is of a class that is implementing this interface. And similarly for multiplication, in this case we again call the calculate ops, and for the multiplication we are simply passing the instance directly to the method along with the two numbers. So if we run the method, we should see the summation and the multiplication of the numbers that we passed. 4 plus 5, 9, and 4 into 6, 24. Now consider we have to provide the implementation of division. Then either we write a new class division in the same way, implement the interface and provide the implementation of the calculate, or there is another way to provide the implementation for the division. So in this case, what we can do is so we will pass something here, then two numbers. So let's say 9, 3. And here we can use something that is called anonymous classes. So we will create the implementation where we need that implementation. So we don't have to create a class from scratch and name it. It will be an anonymous class. So we say something like this. This is an anonymous class. It doesn't have any name and the scope is limited to this method call only. And we say that it is an anonymous class that will implement the calculator, and it is overriding, providing the implementation directly where we are invoking the method. So we will simply say that X and Y. And now if we print the output, so we should see a valid number here. We see 3, that is 9 divided by 3. So you get the idea. We have an interface and how can we use it, but there are better ways now because of the Lambda if the interface is a functional interface. So instead of creating classes or anonymous classes, what we can do is we can simply pass the behavior directly in the form of lambda. So let me comment everything, and we will use now the lambda to achieve the same. So first of all, let's do the summation. We know that it needs an implementation of calculator interface, and we know that calculator is a functional interface. There is only one abstract method. So any implementation that we pass in the form of lambda, the Java runtime will assign that lambda implementation to this method because there is nothing else in the interface. So let's write a lambda to do the summation. We know that the method expects two input parameters, method parameters. So there are two arguments, then the body, lambda body, which is basically to sum the numbers, and then we will pass the numbers. All right. So, okay, did something wrong. It should be like this. Yeah. So instead of passing the instance of a class or an anonymous class, what we are doing, we are passing the implementation in the form of lambda. And the implementation says that accept two parameters A and B and do the summation. The right hand side, on the right hand side of the arrow, we have the lambda body which says that do A plus B. Now when we invoke this line, when the Java runtime will execute this line, it will not execute this code right away, but it will pass this behavior, this implementation, as an implementation of calculate. And when the code executes this line inside the calculate ops method, then the Java runtime will actually call this implementation A plus B, and it will pass the numbers 6 and 7. So let's run it. We see the output 13. Now if we have to perform the multiplication, then what we can do, we will write another lambda, and this time the lambda body will be to multiply the numbers, and we'll pass two numbers, and we have to call calculate ops. And if we run this, we see the multiplication of 8 and 9. So we see how lambda makes it easy. It is so clean if we are using the lambda to achieve the same thing what we were doing with classes and anonymous classes. So just to recap what we are doing, we are basically passing the implementation directly, and what Java runtime will do, because it knows the target is a functional interface and there is only one method in that functional interface which doesn't have any implementation. So whatever implementation we are passing in the form of lambda, Java runtime will actually pass that implementation to the calculate method of the interface. So when we are calling calculator.calculate at this point of time, the implementation that we passed will get executed along with the arguments that we are passing. So that's the benefit of using lambda. So in this video, we saw how easy it is to write a lambda, how to use it with functional interfaces, and how can it simplify the overall logic. So we will see few more things on the lambdas in upcoming lessons, but that's it for now. Thank you.